Take a few moments to learn how, in just 60 minutes, NASA can process a day's worth of new discoveries from the Mars Science Laboratory. The red plains and pink sky of Mars hint that volcanoes, meteors, and flash floods once shaped the landscape. Today, a number of robots, sent by NASA's Jet Propulsion Laboratory, explore the atmosphere and surface of Mars. These rovers are on a quest to find out whether the red planet is, or ever was, an environment able to support life. However, giving instructions to a Mars rover is more difficult than most people realize. Unfortunately, there's no joystick controller a scientist can use to move the rover around. And even at the speed of light, it still takes between 7 and 20 minutes for a transmission to go from Earth, across space, to the rover on Mars. To make matters even more complicated, there are only short periods of time in which scientists can communicate with the rover at all. This makes for a precious window of time in which NASA JPL engineers must determine the next day's mission for the rover. Sometimes they have just a few hours to download data from the rover, then process and interpret that data in order to send new mission instructions back to Mars. When they can speed up the analysis of the data, it leaves more time for science. That's why the team uses Amazon Web Services to spin up hundreds of Intel Xeon E5 processors when they're needed. With the scale and performance of this on-demand computational cluster, NASA JPL engineers are able to drive 12 teraflops of performance for less than $40 an hour. This leaves more time to work on programming Curiosity's next steps. It also enables NASA to get greater utilization of the rover's unique capabilities. Closer to home, NASA JPL scientists also use Amazon Web Services and Intel Xeon E5 processors for other computationally intensive workloads, such as robotic articulation calculations and Arctic climate analysis, all while enabling their researchers to work more productively and cost-effectively. When the team needs more computational power to support these and many other missions, they can easily provision what they need as and when they need it. This on-demand scalability lets NASA scientists and engineers keep their focus on exploring the Earth, the solar system, and the universe beyond.